Oh, I haven't said anything yet. So first of all, thanks everybody who's here. I realized just this morning that I was going up against Mark Reinhold, and lesser men would have wept and run away crying. But I decided, yes, I can still do my SubCut talk. I would have liked to have seen Mark's talk as well, so I'm very pleased that there are so many people here. Thank you for coming out. So I'm here to talk about SubCut 2.0, which is still a snapshot at the moment, although I hear that people are using it in production already, which is great. I'm very happy. I am trying to get the 2.0 final out. I have some fairly strict standards for myself before I release, and one of them is that it has to have some decent documentation first. I'm very happy that this talk is being recorded because this will be some of the documentation that goes out with 2.0. To get people using it. Bones McCoy from the original Star Trek, although I do like Carl, what's his name? Carl Matheson's depiction, is up there because of what he's holding. The code name for 2.0 SubCut is actually Hypospray, and the idea was I was trying to make injection as painless as possible. So that's why I chose that. And the subtitle here is, I work with a very good friend, I love this guy, Runar Bjarnason, who does a talk called Dead Simple Dependency Injection with Scala, and then goes on to talk about monads. And so I came up with, honestly, truly, completely, absolutely simple dependency configuration in Scala, because this, I think, is what most people have seen or used. It's the kind of thing that you've done before if you've used a framework like Juice. This is meant to be familiar, but it's a Scala accented version. Okay, so what does SubCut stand for? It is a tortured acronym that I came up with late one night after drinking too much, which is Scala Uniquely Bound Classes Under Traits. And it's also a shortening of the word subcutaneous, which is the method of injection or doing things under the skin. So I thought that was clever. Why not use one of the other options that are available out there? Why the hell did I sit down and write another option? And believe me, I asked myself this question a bunch of times before I did it. So why not use Juice or Spring? In the Scala world, Cake is a very popular option, and I actually worked with that for a while. I found it had some limitations which I want to talk about. It's very good for certain things. It's not good for the things that I wanted to do with it. And then there's the option of just rolling your own, which is kind of what I did. And then I decided, you know, if I've done this, it's pretty simple. Let's put it out there. And to my amazement, people actually started using it. So, right. So let's take a look at a couple of the other options quickly first. First of all, there's Juice, and I will make no bones about it. There is a lot of Juice influence in SubCut. It was very much a model that I used because Juice is a great option for dependency injection in Java. However, it's not such a great option for dependency injection in Scala. We can do some things better. For one, the DSL is a great inspiration, but you don't need to put class ofs all over the place in Scala. We have a better option, which is type manifests. So that's one way where there was just an immediate win to creating something new that was targeting Scala directly. Another problem is, actually I can show you, maybe I'll show you on the screen. Right here, the annotations are just a bit funky. You find that annotations are not as widely used in Scala, mainly because you don't need them for as much stuff. In Java, annotations are a great big kind of pressure release valve of anything we want to do that isn't strictly in the language right now. Oh, we can throw an annotation and an annotation processor on that and do something to kind of vaguely extend the language. There are better options available in Scala. For one thing, we've got traits, which fill in a lot of the blanks, a lot of the things that you might want to do. On top of that, we have something that blows away annotation processors, which is compiler plugins. And yes, SubCut optionally uses a compiler plugin to make something, one particular thing, a little easier. The other thing about it is because of the way the constructor works in Scala, the @inject has to have parens after it so that it doesn't get confused with the constructor parameters in Scala. There's just a few things that are a little bit kooky about using it. And originally what I started out with SubCut was the idea of implementing JSR 330, which is the kind of spec that covers this stuff in Java now, in Scala. And then I quickly realized, this is all annotation-based. It just doesn't fit. So I went back to the drawing board and I said, okay, starting from scratch, how would I write it? Spring, well, it's either annotations like Juice or it's a bunch of XML. You don't get the type safety. That's a big issue for me. The getting the beans here, you do immediately have to do a cast on them. It's just not, we can do better than that. We can definitely put in type safety. Cake pattern is actually a really good option, and it does something that none of my attempts, SubCut, many of the other options out there can do, which is provide complete compile time verifiability that everything is bound. Okay, as soon as you go to something where runtime bindings are a possibility, then runtime binding errors or missing bindings at runtime are a possibility. Now, I have addressed that in SubCut, but it's through a conventional means rather than a strict compiler means. Whereas Cake gives you, real provability that things are correct. The downsides with Cake are if you're actually trying to reconfigure things on the fly a lot, like, for example, when you're doing a lot of testing, and you're dealing with functional hierarchies, functional testing hierarchies that are deep, you actually get into a lot of work creating new instances of things and recombining the mock things that you've created and the real things you've created, and it's a lot of overhead. There's actually quite a bit of boilerplate. For a language which prides itself on busting boilerplate, there's quite a lot of boilerplate involved in the Cake approach. The other one that I found out just recently, actually, talking to people, I never got so deep into Cake as a lot of these projects are now, but it is incredibly slow to compile Cake. When you start using it heavily, it really, really puts a lot of pressure on the compiler. SubCut is very lightweight and compiles very quickly. So that's another reason. Okay, so let's take a little bit look back at dependency injection history. And this is somewhat of a rationalization. So what was life like before dependency injection was this thing that everybody talked about? I don't know if anybody remembers, but kind of the alternative back in the day was directory lookups. You'd go, I need a database. What is in my Jindy directory? And, by this name, and you go out on the network and you look it up and you get back something and then you use that. And that was known as service location. And it was considered an anti-pattern. It kind of underwent this backlash of everybody said, it's a too heavyweight and it's a terrible way to do it. And they threw it out, okay? And I think that was unfair. Service location actually has a fair bit going for it. And SubCut is simultaneously sort of a bit of both worlds. It has one foot in dependency injection and one foot in service location. And I think it combines the two in a way that makes it very easy to use. So what can we learn from service location and how it can be applied to dependency injection? And I need to put my clicker down because I keep trying to use it and it doesn't work. So starting over, first of all, let's build up, and this is, I wish, and I'm actually talking about this at the Scala user group meeting tomorrow night. This is a library that's written in the way that I wish more Scala libraries were written in, which is that I start with the simplest thing that can possibly work, and I work towards an API that I have in mind. Whereas I see too many Scala libraries right now that are based around a really clever idea, which is great, but then the API ends up all over the place because it's the idea and the cleverness of it that the author was trying to get across. They haven't really thought about the end users of this thing. And so you end up with something that's actually pretty hard to understand and usually very different from what people have been expecting up until this point. So if we look at the kind of approach towards dependency injection, the simplest thing that can possibly work is you just pass everything in that you need as one of the constructor parameters. So when you need a database, you pass in the database that you need as a constructor parameter. Super easy. It's obvious what's going on. It's very easy to navigate the code. You can backtrack and say, what is the database that's being used here? A lot of the things that get lost in Juice, unless you've got some kind of IDE support, they're easy to do with constructor parameters. So what's wrong with them? Okay, the thing that sums it up is whenever you add a new dependency, you have to go back all the way through the chain, and you've got to add that dependency all the way back up to the top. And pretty soon you've got a whole bunch of classes that have multiple things that are under them that have, 20, 25 dependencies being passed around through the system, and it gets pretty unwieldy. Not to mention that right now the Scala refactoring support in IDEs is not really strong enough to cope with add a parameter all the way back up to the top, or to where I need it at this level. So that gets pretty heavy. So where do you go from there? Well, the next obvious thing is you take all of your dependencies and you put them in one place. You put them in a configuration module, and then you just pass that one parameter all around the system. And that's a really simple solution. Okay, so you build up your configuration, and you say everything that needs to be injected, everything that needs to look up something in the system, we're just going to pass that one binding module around, and that will be available to it to look up stuff. And that works great. But what else can we do? This is a good approach, and by itself would be quite useful, but there's some things in Scala that we can use to make this even better. For one, right now you end up passing a binding module around everywhere, and it's something you've got to think about. It's this cognitive load. It kind of looks ugly. You've got to put it in your code all over the place. Scala has this really lovely feature that I've come to respect more and more. It enables so much useful practical functionality in Scala, which is implicit parameters. Amongst the things that it's brought us in Scala is type classes, which are a wonderful solution to a lot of the problems that you would normally use reflection for, and it's all compile time verifiable and everything like that. And the idea of an implicit parameter is that you specify that you need a parameter in a parameter list for a class like this, and you mark it implicit, and then if you don't fill it in, the compiler looks around for one that's implicitly in scope. And as an added bonus for this, when it's implicit, when it's marked as implicit in a class, it automatically is put into implicit scope for anything else that that class creates. So suddenly, by making something implicit at the top, it automatically gets passed in to everything that needs it. Okay? And that's at any level. The chain remains unbroken all the way down. So that's really nice. That was the idea. That was the moment at which I thought, hey, this could be really good. You can just create new things. That's another thing that I didn't like about using Juice, was you lost the ability to create new instances whenever you wanted to. And in particular, you lost the ability to use your own constructor parameters in there. You had to use a lot of factories to get that kind of thing done. You'd inject a factory, and then you'd use the factory to create instances of things. With SubCut, you can actually have your cake and eat it, so to speak, because you can, that's a little pun there, but you can actually have constructor parameters, and you can still have an implicit module that's passed around. The implicit module can be used to fill in the configuration you need, but you can still create new instances whenever you want to. So this is what, this is the idea, the core idea behind, oh, by the way, I should say, stop me at any point for questions or heckling or whatever you want to do. But this is the core idea behind SubCut, and it's very simple. It's the one idea that you have a configuration and it gets implicitly passed around for you. It's not radical, it's not new. I hope that I just put a library together that makes it easy to do and easy to follow recipes that you can use to do this. What does SubCut look like? It looks like this. You've actually seen the core of it, the implicit val binding module that is passed around the system. The rest of it is basically just a DSL that makes it easy to put the bindings in place. It's a nice, easy-to-use DSL. It leads you through the process of saying, this trait is served by this instance or this class. And once you've created that, I'll talk a little bit about the benefits of doing it. But for one thing, the binding modules are immutable afterwards. And for another, they are thread-safe and eminently parallelizable. We have thousands, or I think we're up to about 1,000 tests now that run in parallel on some of the systems I've used. They have no problem in allowing you to alter parts of the binding module because you get a new copy every time. It's very efficient to obtain a new mutable copy, make some changes, and then it becomes used just for that one test, and it doesn't interfere with any of the other tests that are running at that time. So it's very nice and parallelizable. So what it looks like is this. You extend, or sorry, you mix in the injectable trait. That brings in just some convenience methods that let you do things like this, injecting a user page trait. And that will be served by whatever the binding is. So it just gives you an ability to bring that in. It also, when you mix in injectable to a concrete class, it requires that there be a binding module available in scope. And so you have to, at that point, put the implicit val binding module in. Now, I've got a fix for that as well. That's where the compiler plugin comes in, but I'll talk about that in a minute. So at its most basic level, SubCut looks something like this. You can create a new trait. That doesn't have to, because it's a trait, that can still remain abstract in the binding module. So you don't have to put in a binding module here. But this is the trait that we're going to bind in. Or this is the trait that we're going to bind under. And then we have a user manager impl that implements that trait. And it's also, by the way, these things are also injectable. So they can have their own injections when they're created. But this one has, well, this one injects a user page. We have the definition here. Then user page itself is injectable. It can have a server URL, so this is just straight configuration injection. You can name, there's various ways of identifying bindings by more than just their type. Having an injection for just string is pretty useless, because there's probably going to be more than one string that matters to you for configuration. When it's a rich type, the type itself is enough to identify what you want to do. But when it's a string or an int or something like that, you want to say, I want the string that represents the LDAP server, or I want a string that represents my web service, or my database URL. So you can identify them by both the type and the identifier, and there's various options for identifier. This is a Scala symbol if you haven't seen it. It's a lot like a Ruby symbol. It's very convenient. You can also use strings, and with 2.0, you can use strong types now as well. That's a little enhancement that I put in for 2.0. Yeah?
Why do you need to have the mixing injectable in the input?
It's just to give you the oh, sorry, yes.
Why do you need to have the injectable trait mixing in the impl when you have it in the user manager trait?
Oh, I don't. That's because I have it in the trait. I actually don't need it in the class here. Although occasionally I put it in there just to make it more readable for anyone who's looking at this to be able to say, oh yeah, this is injectable, so this is okay.
Do you need it do you need it in the trait?
In this case, you do not need it in the trait.
So you could put it just on the.
That's right. But if I actually wanted to use the inject method
like
in the trait, then I'd need it in there, and I'd probably still put it in the class as well, because somebody using my class would also need to know that if they make a new one of these, they can read the fact that they also need to provide an injectable. The compiler will tell them that as well. That's another nice thing about SubCut is when you try and compile this, if you accidentally break the chain you have to forward the implicit configuration on the way down. If you forget to do that, the compiler will not compile. It will tell you that you've broken the chain. So you have to make the superclasses of the things of the class that you're creating class, if you like. That has to also be injectable. You have to have an unbroken chain for the module to be passed down. It's actually not nearly as draconian as it sounds, particularly when you use the compiler plugin, which I will cover in a bit. That makes it super easy. But that's the other thing I was very keen on, is not everybody likes compiler plugins. So you can quite happily use SubCut without it. You just need to put this parameter in. Those 4 words there drove me nuts. That was the only boilerplate in SubCut that I couldn't get rid of, so I spent a month learning to write a compiler plugin just so I could eliminate those. There is no documentation for compiler plugins. It's very hard to figure it out. Okay, so the SubCut Bootstrap looks a bit like this. You can, there's 2 ways that you can choose to basically start the whole process. One of them is, these are just main applications. So this is the extends app. Who here is not familiar with Scala? Don't be afraid to. Wow. Okay. So very, very quickly, there's a nice little pattern in Scala where you can just say an object, my main object extends app, and then anything that goes inside the curly braces runs as though it was inside of a def main function. So that's the magic that's happening there. But when you do that, when you extend the app, you can also mix in injectable at that point, and that lets you use inject. So this is one way of starting the whole process, is your main application, you define the binding module, you make it implicitly available, that's the kind of the contract, that's the first thing. You say, this is the binding module I'm going to use, and then you inject the instance of the thing that you want to use, and you can start using it straight away. It's all type safe. so the compiler can check everything. The other option is, like I said before, you don't lose new, okay? So instead of mixing in injectable at all, we can just have our application. We can still make an implicit binding module here, and then we just do a new on it. And that's great if you actually want to put in constructor parameters, of course, because you may want to put in some of your own constructor parameters. And so that's another option. You can choose either way. And that's very much what SubCut is like. You choose one or the other. You can make new instances if you want to, so on and so forth. Okay, so injecting styles. There's 3 ways of actually performing the injection. One of them is what I call the required or the direct way. The direct way means that I am looking for one of these things. I'm looking for a thang in this case. If there's not one there, that's going to be a runtime error. Okay, this is one of the limitations. This is one of the reasons why Cake still has the prize for complete compile time verifiability. However, I don't usually use this form. There's another form that is much safer that avoids the runtime errors. But this, if you really, really know that this configuration is going to be there, or if you want it to be an error if it's not there, then this is the form you can use. You can just say inject this trait. You have to have a binding for it. One of the requests I've had for 2.0 is just-in-time bindings for if you're injecting a class that can be actually constructed on the fly, then make a binding for it automatically. I'm not going to put that in 2.0 because I want to ship 2.0, but I am looking at the option for 2.1, so that will be something that I try and add in at that point. I hadn't really thought about it before. My own solution, which is on the next slide, I think is the way that I tend to use it. So I don't look at these ones a lot, and I don't think enough about them, but other people like them. The second way is the constructor parameter style, which is the juice style of things. And that is, in juice, the way it works is everything is still in your constructor parameters. It's just that you don't have to fill them in anymore when you use them. Instead of that, the juice injector can fill them in. And you don't need to do pass forward. You just need to specify the ones that you actually want at that level. You can do the same thing in SubCut. You can specify the injections that you want. The way you do it is, because we're good Scala developers and we don't like nulls in our code, so we use option everywhere to avoid null, is you make it an option of that type. You mark it as equal to injected. That's just actually a rename for none. It's an alias for none behind the scenes. And then you use a inject if missing. So the idea is if you pass it in as a constructor parameter, it uses the one you pass in. Otherwise, it goes to look for the one that's bound in the binding module. Both of these can lead to runtime errors. The one that is safe, this is the one I use pretty much exclusively now, and it has one tangible or very obvious advantage, which is that it doesn't fail. If you're lacking a binding, it will not fail. It will not give you a runtime error. The less obvious but very useful one is this actually works really nicely with IDEs when you're trying to navigate through the code. So the idea behind this is that, like Juice and like other dependency injection frameworks, you can reconfigure things as much as you like in Juice, but where it's really intended to shine is for testing and for mocking, okay, for enabling a kind of easy substitution during testing, and particularly parallel tests and things like that. And the idea is that in most programs, not always, and you've got the other options if you don't want to use it, but in most programs you have a standard way, a standard implementation of something. When you're using a database, you have a standard database that you use. It might change, but it's easy to change it in one place if you do that. But the idea is that if you use this form, this is called inject optional, what it does is it looks for a binding. If there is one available, it uses the binding that's available. If not, you use the get or else, and you fill in the standard one that you want it to use. And this makes it safe, okay? There's no more runtime errors when there's a missing binding, because it falls back on the one that it knows. It falls back on the standard one. And this has another advantage, even, which is that you can have a completely empty binding module this way. You only fill the binding module in when you want to change things for testing. And if you do that, SubCut is really ridiculously fast, because if you have an empty module, I have a check in there to say, hey, it's an empty module. Guess what? You don't even have to go and try and look up the binding. Just go straight in and use your standard definition. And so it short-circuits the whole thing. But when you come up in testing, you can say, okay, now I really want to put a mock in here, so mock it out for me. So the nice thing about doing this is I can say here the web search is inject an optional web search, get or else. It's all standard. This just returns an option of web search, and when you do a get or else, it either gets the item or it executes the function on the right-hand side of the get or else. And that does a new Bing search service. I think I gave the original one of this at Google, so I had to put a little Bing dig in there. Anyway, so that's one way to do it. You can do inject optional of int with an ID to identify it, and then you can just say get or else, and the standard is 15. So that's our thread pool size. We're going to go with 15 threads unless we override that. You can do flight lookups and so on and so forth. And this is the way I use SubCut, and this is the way I recommend people do use it. It's safe. You can immediately go and say, hey, I want to see what the standard web search service is. You go straight back to the definition here. You command click on it, or control click on it. It takes you back here, and you say, oh, it's the Bing search service, and you command click on that. So you get the navigation through the IDE as well. It just seems like a win all round. Okay, so some tricks that we can do that I think is a lot harder in other languages. The other thing I should say about SubCut is I never even considered other languages. This is totally a Scala dependency injections or configuration solution. There's no way this will ever work with Java or probably most other languages. It is for Scala users, this thing. You may want to look at other options if you're doing other languages. But one of the advantages we have is we have real type manifests in Scala, particularly in 2.9. That means that it can tell by injection a list of ints from a list of strings, from a list of ints. All of these things can be bound. The right type will come in. They can all be different contents. Okay, so you can have as many objects inside of one another. You could have an entire object model, an entire domain of case classes holding lists of other case classes. All of those could be bound to one thing, which will always get substituted in, and it will always be type safe. So all of this is compile time verifiable. If I bind a list of int to a list of ints, that's fine. But if I try and bind it to a list of strings, it'll give me a compile error. If I try and pull out something, I know it's going to be that type. Behind the scenes, you don't want to know how much casting I'm doing to make this work. But the point is I've tested it all, and that means you don't have to do the casting. There is the API itself is type safe. So, you know, all the type erasure is handled for you, and you never have to see it. Okay, providing the implicit. The one way to do it is a constructor parameter where you say implicit val binding module of binding module. Sometimes you can't do that with third-party libraries. A great example is Wicket and Juice. When Juice came out, you had to get support in Wicket before you could use Juice with Wicket. That was one of my design goals with SubCut was you should be able to use it anywhere with any other libraries that you want to. And so I figured out that what I would do is allow you to mix in a binding module as well so that you can create a standard implementation of this class. You can take any class that you've got that requires the bindings, and you can introduce just one new lightweight class based on it that fills that in for you. And then you can create new instances of that from Wicket or anything else that doesn't know how to fill in the binding module. So you've got the option of either providing support from your library or using it with a library that's never seen SubCut before. Now, this comes to the point where I dove in, and this is one of the reasons why SubCut 1.0 took so long to release, was that those 4 words, the only boilerplate I couldn't get rid of was the implicit val binding module, which had to go everywhere. I wanted to make those kind of long because I didn't want to just use bind, because you might want to use that as an actual variable name in your class or something like that, and I didn't want to take a name from you that you might actually use. I figure binding module is pretty safe, but it means a lot of typing. It means that you've got to type this thing a lot. So eventually I was like, okay, there's got to be a way around this. And what I did, as I said, was sat down and wrote a compiler plugin to eliminate that. And originally I was going to make this this was going to be an annotation. I was going to say, okay, this is auto-injectable. And then I thought, you know what? I can just make it a trait. It's even nicer. So there is a trait called auto-injectable. It adds nothing to injectable other than a different name. But the Scala compiler plugin that you activate goes through and looks for anything that extends auto-injectable, and then it automatically fills in the abstract syntax tree, it automatically fills in the implicit for you. So now, all you have to do to make a class injectable is to say class blah, 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 extends auto-injectable. That's a mix-in trait, and it does the implicit for you. If you don't want to use the compiler plugin, I totally understand. It turns me off when some libraries require compiler plugins. If you don't want to do that, you just end up putting this in a lot. I think at some point, if you do enough of those, you'll probably end up using the compiler plugin. It's very lightweight, and it gives you some actual more useful error messages as well. So it's got a couple of little bonuses. Okay, anatomy of a binding. So that really covers the theory of SubCut itself. Most of the rest of SubCut, it's a very small library. One of the other things that took me so long to release 1.0 was taking stuff out. I spent a long time paring it down to the smallest API I could possibly make it. And so once I figured out I couldn't remove anything else, it was ready to go. Most of what SubCut is a DSL that helps you make the bindings. And I wanted to do this because I wanted there to be a kind of cookbook, a recipe solution for people to follow, which I didn't feel that any of the other options really provided. Like Cake is not that straightforward. You need to know something about, how Scala works and a little bit about self-types and abstract definitions and things like that before you can get it to work. And what I wanted with SubCut was a getting started document that said, here's what you do. You write a few of these, they're obvious. You write this implicit val, and then you just start creating new classes, and you're done. So that was where I was headed with this. So the binding module, they all look like this. The anatomy is, you say, I want to bind, then you give it a trait or some kind of type that is a super type of the one that's over here. That's enforced by the compiler, so you can't get that wrong. Then you give it what it's bound to, and there's a couple of different options. This will use reflection to create a new instance of this thing, and it will inject the thing that you're putting in there. This is another potential source of a runtime problem if you try and inject something that doesn't have a default constructor, or at least a constructor with only one binding module in it. So this is another form I don't use. I use the safer form of toSingle. This form here is all compile time verifiable. Oh, that's going to go on to the, no, that's good. This is all compile time verifiable. So I tend not to use this, but I know people like the cleanliness of this one. Okay, it reads very nicely to be able to say bind robot action to new instance of roving action. And that just reads really nicely. The second one, this form will create a new instance every time. This one will use a single instance, and it's whatever is defined in this function. This is actually although it's written very cleanly to look nice, this is a by name function in Scala, which means that whatever code is in there will be evaluated depending on what the semantics here are. In this case, it's a lazy evaluation the first time, and then it always uses the same instance after that, and that's why it's toSingle. But you can also use toProvider. There's other ones. So that's the anatomy. You have binding, the type, optionally an extra identifier so that you can tell the LDAP server URL from the MySQL server URL in the case of a string, and then the thing that it's bound to. And they all look like that. This is new for 2.0. You'll see here, this is the strongly typed ID. So you can now have any object, you can just create a bunch of objects that are your IDs that extend binding ID. And those can then be used for binding or for identifying bindings in the system. This is nice because it gives you code completion and yet another form of compile time verifiability. So I'm pushing more and more to get this all checked by the compiler before you use it. The problem with symbols is you can mistype them, and that means that it can't find it when it tries to look it up at runtime. So that just removes one more source of potential errors. Okay, so Singleton style, this is where you have a single instance that always comes back, no matter how many times you ask for this thing. This is the form that is most compile time verifiable. You just say module bind animal toSingle, and then we just create a new cat, and that new cat is the one that will always be used. It doesn't create a new cat each time. It evaluates that, but it waits until the first time you do it, because that could be a heavy operation. So it waits for somebody to ask for an animal, and then it says, oh, I don't have one yet. I'm going to run this, and then it uses that same instance forever. Likewise here, you don't have to have the curly braces, so this is a slightly more readable, flowing idea that you can just say module bind animal ID by donkey to single new donkey, and then we can actually use the module as well as part of the configuration. So donkey itself can be injectable. To module single, this one is new. This is new for 2.0, and so is the one below it. So there was a bug. How long have I got, by the way? Another 15 minutes. Good, okay, we're about on track. So there was a bug in 2.0 that, in 1.0 that nobody actually hit except me. Nobody still has hit it. Nobody's ever come back and say, hey, you totally messed this up. Which is the problem with implicits, is they're filled in at compile time. And when you create a singleton, although the module itself is immutable, you can, at any time, open up and get a new copy of the binding and reconfigure stuff in there, and then use that from then on. The problem was, in certain circumstances, if you had a class that itself was injected with a whole bunch of stuff, if you change one of the things way down that was injected to that class, because of the way the implicits were resolved, it would never pick up that configuration change, because when you asked for the class a few levels up, it would be the same instance as when you first created it in the other module that it came from. And so I put a fair amount of work in 2.0 to make something called a module singleton. And a module singleton is a singleton for that specific module. When you open up and reconfigure the module, when you create a new one, it rebinds all of these. In fact, it wipes out all of the bindings for these module instances and waits for the next one to be asked for. And then it gives you a new one based on the current configuration, no matter how deep it is. So this is probably the form you want to use now, the two-module singleton form. And the way you use it is it actually passes in, it loans the current module to the function that fills in that information. If this doesn't make sense to you, if you just sit down for a minute and think about it, it makes total sense. But wherever we define this, a new instance will always get handed the current module, whatever it is. Not the one where we're defining it, but the one that's in use at the time that we ask for a new instance of this thing. And that will then create this module. And one of the nice things in Scala is that you can mark that as implicit on the way in. So then that implicit gets passed down through the others just like it would with an implicit val. So this is really the sweet spot, the last one on this slide, which is you bind it to a module singleton, you implicitly take the module in, and then you create the singleton based on that. Make sense? Okay, good. Reflection style is a lot easier. This is cleaner, but as I said, the problem with reflection is it is reflection. If you don't have the right constructor, then you will get an exception. You'll get an exception when you try and bind it in that it can't create one of these things. And you also can't give it constructor parameters when you do this. However, what's nice about it is it's very clean. It gives you, in this case, it gives you a new instance every time that you ask for it. There's also a module instance of, and that will automatically inject the module for that item, and it does the right thing. It resets when you create, if you reconfigure the module and make a copy of it, your new module will have that binding removed so that you have to recreate it again with the new configuration. Provider style, this is the most useful form. So those three scopes are the ones that I give you. Okay, those are the scopes of a new one every time I ask, a singleton for the module, or a singleton for the entire system. The provider style is the most flexible, and you can do whatever you like with this. This is a function that runs. Again, it's compile time checked, so you can't return something from here that isn't an animal. It will fail to compile. But you can do whatever you like here. So this is where you can introduce your own scoping. Say, for example, you have a user session that's attached, or maybe some thread local. I'm actually thinking about adding thread local for a future version of Scala because I would use it. And I've actually got my own implementation now. I'm just thinking of promoting it so that you actually have a thread scope that's a singleton for the current thread that you're in. And that might be something that's really nice to have. But in the meantime, if you want to do that, you can simply do that by writing your own provider module. And any kind of code can go in here. It can go and get a current user session and return something that's always the same based on that particular user. You could return something that's based on Google's or Guava's cache builder, so it does very efficient concurrency, concurrent resource presentation. Oh, thank you. 10 minutes. So that, the provider is really the sweet spot if you need that kind of power. And there's a form of the provider that also takes the module, so it's resettable in between module reconfigurations. Yeah.
If you go back to a few slides to the
Oh.
Okay, if you go back a few slides to where you use into single here, why can't you put in any code where you now have a new cut?
You absolutely can put any code in here that you want to. The only thing is that this code will always be treated as a lazy evaluation. So it will do it one time for either the whole system or for a module. With a provider, it will run this code every time you ask. Whether you actually create a new instance here or whether you do something different and give back a similar instance based on the thread or whatever you want to do, that's where you control this. So to provider is the power users option. It's the get out for none of the things you gave me to make life easy actually work. I need something different. I need something that's a user session or anything like that. And so that's the provider style. I use this one quite a lot because I'd say 80% of the time module singletons are what I want. But there's enough of a time, 20% of the time is when you need more power. You need the provider function. Unbinding was an interesting problem. There's the semicolon inference in Scala is pretty good, but there's a problem when you do something like this, and you just have an unbind method that has a type parameter, but has no other parameters on it, and it can screw up the semicolon inference. And so while module unbind is there, if you find that you need to put a semicolon at the end, I hate semicolons in the code. They remind me of cockroaches now. So what I provided was an alternative form where you say bind it to none. And that's like saying unbind it. And this form doesn't screw up the semicolon inference, so you can write it in a fluent style and not worry about that. Defining modules. The nice thing about the modules is they are constructed in a mutable way because that makes it very clean to use the DSL. But as soon as they pop out from the construction phase, they are completely immutable. And the only way you can then mutate them is to ask for a new copy, which is then mutable. And that then can be made into an immutable one for your tests. So that's the way it works. Once the module is constructed, it's immutable after that stage. And because of the way the construction is written like this, there is no chance of any kind of thread problems because the construction happens in a function that's passed into the constructor of that thing. So the only thing that knows about the module when it's being constructed is that one instance. There's no chance that any other thread in the system can get a hold of it. And by the time it emerges from the constructor, it's immutable. So that's the way that works. And so it looks like this. You can create a new binding module, and what happens is you get loaned back the module that's mutable to be able to use it. And then you bind in what you want, and as you leave the creation of this, it becomes an immutable configurator. So that's one form. There's another option in convenience option in 2.0 that I actually. Oh, that wasn't right. Where do we go? I was trying to scroll down, and I forgot I was in slides, and you can't do that. I was just trying to bring it up a little more on the screen, but you guys can see it anyway. So this is the new binding module method that you can import if you want to. You can just say import new binding module, and it's a bit like importing actor.underscore or actor.actor. It gives you a really convenient way of just saying, I want a new binding module right here. That's the module, you bind it in, and it's done. And it's just kind of an inline, very convenient way. It's very useful for testing, this one, because it's very lightweight. Importing the module, this is a little trick. So up until now, I've shown you that you always say module.bind, and that dot in there was driving me nuts as well. It's like, I really want it fluent. What you can do is you can actually just say, at the beginning of a new binding module, any way you use a binding module, you can just say import module.underscore, and then bind comes into scope. So you can then just say bind action to single new walkies. I like this style. I think that's the way I tend to do it. It just reads very nicely, and you don't have to type module dot each time. The identifiers, there's 3 ways you can identify things, and they're all interchangeable. You can make, this is the form I use now because I love it, and it's type safe, and it gives you code completion in the IDE. You actually create an object that extends, thank you, 5 minutes, that extends a binding ID, which is a new object, and you can use those, anything that extends binding ID, you can use as an identifier to bind or in your bindings. You can also use, these were from 1.0, and I didn't want to remove them, and they're still occasionally useful if you're just doing a quick and dirty thing. You can use a symbol or a string, and they're all interchangeable. So if I used mammal here as a binding ID, but I also referred to it as a string, mammal, those are the same thing. They bind to the same thing. I don't know that I'm crazy about that, but it's the way 1.0 worked, and it would break things now to change it for 2.0. So, you know, maybe when I do a 3.0, maybe I'll actually, what I'd like to do is retire the forms of symbol and string altogether and just have strong binding IDs from now. That was a lesson learned from 1.0. Module merging, I'm going to skip through these really quick, but you can merge modules together very easily. There's two ways to do it. One of them is to create a new binding module, and then you can use this kind of inserter operator. And that, because I don't like just operators, this is another pet peeve of mine with libraries that give you like weird operators that mean nothing to people. I think this one's okay because it kind of shows that it's inserting something from this. But you can also just say dot merge with replace as well. These are aliases to the same thing. Okay, so if you prefer the spelled out version, if you want to do a bit more typing, you can just say module merge with replace. And that's what it does. It brings in the other module and it replaces anything that's there. So you can merge in a bunch of modules and then you can start your own bindings. There's also an on-the-fly form. Okay, and this is based on the parser combinator thing. The tilde just means followed by or and then. And again, there's a and then alias to this. If you want to spell it out, you basically say my binding module is the roving action module and then the robot provider module. Okay, testing with SubCut. This is the real payoff. How am I doing? 3 minutes. Good. This is the real payoff. This is where it gets good. So you're in a test. The test framework doesn't even have to know about SubCut. Although if you use Scala test, it's actually very effective if you create a SubCut fixture. If you get to that level, you can create a SubCut fixture as part of your class. And then it's really sweet. The whole integration is really sweet. But let's say you're just in any old testing framework or indeed just in a part of the program where you want to reconfigure things. What you do is you take your standard bindings, whatever they are. It could even be the current module that you've got that's been passed in explicitly. You can grab a hold of that module. And then you can just say .modify bindings. And what you get is you get handed back, you get loaned back a mutable copy of the bindings that you've already got. And then you can change what you like in there. The original is unaffected. Any other tests that are running in parallel are unaffected. But your test, within the scope of these curly brackets, has new bindings, whatever you want to put in there. So you just open it up. You say, these are my test bindings. I'm going to mark them implicit, so they're used as standard for anything that I create that's new in this test. And then you mock it. You create. I've made up a mocking thing here, but it's not a stretch of the imagination to use, you know, substituting an easy mock or Scala mock or something like that. You make your mocks, you bind them in, you create the new item that you want to test, and you do the test on it. And it's really clean, and it works beautifully. And believe me, it's thread safe because we run a lot of tests in parallel, and it's been working fine. Not seen a problem there. Integration with other libraries. Oh, 1 minute. Okay, integration with other libraries I mentioned, so I'm not going to spend a lot of time on it, but the idea is that you can always take something that's an injectable page like this, and you can make a bound page which just injects it with the module that you want it to use as standard. Then you can use something like Wicket, which doesn't know about these injections. The standard one is there, but you can still test it by testing the injectable page. And this adds nothing more than the module that you use as standard. So it's pretty safe. You don't need to test this one. You need to test this one. All right, and then finally, I'll leave that up there. Actually I won't, but it's a real-world example. It proves to you that I don't just make this stuff up. We use this in reality. This is a non-trivial test that tests web services and lookups of genetic data. They're all incredibly slow, flaky services. They're all mocked out in this, and the result is a test that runs extremely fast, and it's very easy to read. There's not much overhead in terms of what we need to set up to make this work. Okay, so the last thing I'll say is about Escalate Software. This is the company that I own with Bill Venners. We do training for Scala, open and in-house and custom training if you want something special, consulting, mentoring, and so on, and you can find it at escalatesoft.com. Right, thank you. That was a lot of material in a very short time.